Ron Hardwig, and I would like to talk to you about tornadoes. How, why, when, and where they form, and what is their source of energy, and why do they dissipate. I've been interested in tornadoes ever since I was a little child, and was old enough to understand that my great-grandfather was killed in the tri-state tornado on his birthday, March the 18th of 1925. I started looking at tornadoes and becoming interested in the late 1980s. I was flying back from a business trip out to the West Coast, and as we were flying back, the pilot came on the intercom noting that we would be arriving in St. Louis 35 to 45 minutes early, as we had been flying in a jet stream up at 32,000 feet. This got me to thinking about the jet stream and the fact that I always heard the thunderstorms go up to about 30,000 feet. More recently, we had a tornado in Illinois, specifically Washington, Illinois, on November the 17th of 2013. This came within a half a mile of my daughter's home, and even closer in that they were at church at 11:10 in the morning with really no shelter, and it missed the church by 1 block. As I mentioned, I've been thinking about tornadoes for some time. And on that airplane coming back from St. Louis, or coming back to St. Louis, that's when I came up with a hypothesis. I registered that hypothesis with a lady I'd used for my patents that I'd had, just noting the date, and I believe it was April in 1996. After that, I started keeping data as best I could on where tornadoes form compared to the jet stream and thunderstorms underneath. In 2005, I was able to start getting online and check the location of thunderstorms and tornadoes by looking at the jet stream online. I continued to pursue trying to contact meteorologists in the area, but I was always told that they knew everything there was to know and that I really didn't have anything to add to it. With the recent events, I felt I had to do something to set forth what had started out as a hypothesis. And in the spring, actually January through May of 2008, I tracked every tornado and where it happened in the United States and where the jet stream was at that time. In every case, the tornadoes form under the jet stream and dissipate once they go out from under the jet stream. At that time, I took my hypothesis and wrote it as a theory, stating that the tornadoes are caused by the Venturi action of the jet stream, which is a streamlined flow, airflow. I know most people, when they think of a Venturi tube, don't think of a streamlined airflow as that possibility. One thing else that got me started this year was the November issue of National Geographic. Once again, I believe it's on page 48, all they profess is to say that the thunderstorm, with the rotation of the warm air coming up from the south, the cool air coming down from the north, rotates and causes a tornado. I've never been able to completely get that through to my mind because that seemed to not go along with Newton's third law of motion. For every action, there's an equal and opposite reaction. We see the action of the tornado with the things going up in the air and the damage done on the ground. Where is the downflow? Where is the downflow of the equal and opposite reaction? Yes, we have downbursts, but not necessarily with the tornado. And they are not consistent along with the tornado. I have another theory as to how tornadoes form. In fact, I have data from back to 2005 supporting my theory. And to me, it is actually a fact. I've tried and tried to meet with meteorologists, but I always get the same thing. Actually, finally this year, in October, I called my local weather station down in Lincoln, Illinois, and talked to the two fellows down there, asked them if they would give me 5 minutes to present my theory. Could I come down? And they said yes. We ended up talking for over an hour and a half, and they thought I had very valid points, suggested that I do further research, get a grant, or contact the National Weather Service out in Norman, Oklahoma. I've tried to contact these people, but I still get the same thing. Every time they say, we know what causes it, and if you don't have anything more to say, don't bother us. That's almost a quote. Now I'll go into my hypothesis, which started as a hypothesis. Then I presented it as a theory in 2008, and I've got data to back it up at this time. Two noteworthy things in this research done in 2008. There was a tornado out in Washington State. How many times do you see a tornado in the state of Washington? And lo and behold, would you believe that there was a thunderstorm out there, and it happened right under the jet stream. Another one I heard online, and I checked out that there was a tornado in Portugal. How many times does a tornado hit Portugal? I looked up the jet stream, and sure enough, the tornado that happened right under the jet stream. Let me go a little further now. By the way, anybody like to contact me, I would like to hear from you. Any meteorologist, anybody that has some scientific background, I would love to talk to them. And you can reach me at rsdatainc@aol.com. I'll put this back up again. My name is Ronald Hardwig, as I said. Now then, let's go to a little further here. When we talk about a Venturi tube, this is the most normal thing we think of. A Venturi tube, you have a high pressure gas of some kind, or water, it can be gas or water, coming in through a restricted tube, going out through a bigger opening, and as the air goes out, or gas, whatever you're using, the water, it sucks up whatever's down here. Whatever liquid, gas, liquid, whatever you have down in here is sucked up by the Venturi action and forced out the other side. Couple things that people would be familiar with. If a lady uses a perfume atomizer, she's actually pushing a little bulb out here, squeezing it, forcing air through, spraying out some of the perfume. Another way this can happen, have you ever heard of sandblasting? Sandblasting, they do the same thing. We're talking small solids. You have small solids down here, you force a high pressure air through here, and it blows out the sandblasting sand to clean off the rust of anything you want. I have another way that it happens. I happen to own antique steam cars. One way I can fill my water tank for that car is by using steam pressure here. I force steam in. I put a tube down into a pond or a stream up to approximately, of course you can't do it much more than 29 feet. Normally we're looking at 10 to 15 feet. But I can fill my water tank. This goes into my water tank in my car with an overflow, and I can fill my water tank faster than I can fill it with a garden hose. Now that's typically what you see in a Venturi tube, in Venturi action. But there's other ways you can have Venturi action, and that's what I really want to talk about. Let's get rid of this. And I'll show you what I've drawn on the top of the page here to start with. Let's say we have a railroad train going down the track. It's going to our right. Let's call this a streamline train even. And it is moving somewhere at a minimum, and this is, I say minimum because this is what I've found to be the cutoff point, of 70 knots, which is approximately equal to 80 miles per hour. Now, as that train goes down the track, something happens. The air alongside that train is pulled along with it. That air, and I don't know if they got the name because it is a train, but they call that entrained air. As this train goes down the track, both sides actually will get this happening. As the train goes down the tracks and the air is pulled along, it creates a little bit of vacuum along with the entrained air moving along here with it. In fact, in my 1958 physics books, there's just 2 sentences on this. But it notes about entrained air and how people are cautioned not to stand too close to the train lest they be pulled into the side of the train by the entrained air. They could be pulled in. Now we're looking down on this train. Now let's change our view. Let's say we're now looking at the side of the train. And we have ground down here. We have earth. We have a little house or any other structure. Now let's say instead of this train, let's let the train be the jet stream, which is flowing up here. Somewhere between 70 knots and at least 70 knots or approximately 80 miles an hour. Now a jet stream has streamlined flow. Just as our train was a streamliner, you have streamlined flow of air. And this happens somewhere in the 30,000, above the 30,000 foot area. Jet streams go across the United States all the time, normally, basically from east to west, but they will bend north, they will bend south, they will curve. But what I've seen time and again, if we get the cold air coming in, or the warm air coming in from the south, overriding the cold air coming down from the north, we get rotation. Everybody agrees that we get rotation. We get vortexes in this, where the two meet. Now, what started out as a hypothesis, I declared as a theory. I think I have enough evidence to prove it as a fact. Once one of these vortexes reaches up to the jet stream, just like a streamlined train, if that vortex reaches up to here, the entrained air within the vortex and the streamlined air of the jet stream passing over the top is what really creates a tornado. The more we pull out from the center of the tornado, the more air we pull out from the center of the tornado, the more it rotates and gives an outside centrifugal force due to the Coriolis effect. The more it spins, once it starts, we now have a tornado. I've done a few rough calculations just to give you an idea of what can happen. If we say that the diameter up here is approximately 2 miles, we'll round it off to 10,000 feet, and the diameter of the tornado on the ground is 400 feet. The ratio of those two areas is actually their square, them squared. I won't go through the calculations, but I will tell you this. If we had just 0.001 pressure drop, say we had 14.8 psi, if we had a 0.001 pressure drop over 10,000 feet, down here it would equate to 0.625. We have now dropped our pressure from 14.6 down to 14.175. All that air going up in the tornado. Yep. We've also answered a couple other questions. As I mentioned before, I never could figure out how a tornado, we see all that air going up, where's the equal and opposite reaction? With this theory, hypothesis, and what I actually declare as fact, we now have equilibrium, because the air being sucked out up here, in fact, with the jet stream, is in fact the action. The equal and opposite reaction we see is the tornado on the ground. Now let me go a little further. As I mentioned, our daughter just was missed by the tornado. They were in church. I think most people in the town were in church, luckily. And the tornadoes did not hit the church. Let me go a little further and show you just what happened that day. I'm just going to draw the Midwest here, not the whole United States. We're going to draw the Midwest. And just rough drawing, Lake Michigan, some of the other Great Lakes over here. But the main thing I want to get to is Illinois, here, Indiana, here. We got Michigan, of course, and we got Ohio, and the Ohio and Mississippi rivers coming down. That day, there was a jet stream over Illinois and Indiana. That jet stream basically came across something like this. Maybe a little further north to start with. We had a storm front coming in. from the east. We had a meeting of the storm about like through this. And that storm front was moving in this direction. What I saw and checked out and what happened that day, as the storm front went over Peoria and Washington, right in this area, a tornado started. And what I saw the rest of that day was this. As the storm front moved on, this original storm front here with the tornado, and the tornado is embedded in the thunderstorm. It moves with the thunderstorm. The thunderstorm was moving at 60 miles an hour. The tornado was moving at 60 miles an hour. But what happened? As this tornado went across, when it got over here, out from under the jet stream, it dissipated. But what did happen, as this storm front continued to move, every time all along here, new tornadoes would form and they would dissipate once it came out from under the jet stream. This happened time and again. This is what I'm seeing happen. I would like to have anybody review my findings and get in touch with me on my website, my email address, rsdatainc@aol.com. I have tracked tornadoes, probably 300 or 400, and in every case, they form under a jet stream. And I think the one thing that people overlook, everybody tries to say it's all within the thunderstorm. They don't see how you can have a jet stream causing that thing, how you can have a Venturi action. But you can have Venturi action with the jet stream going over the top of it with the streamline flow. I do a little experiment, a little, I'll say, little thing to show this happening. Put a straw down in a glass of water, take another straw and blow over the top of it. You have streamline flow blowing over the one tube that's down in the water, which would resemble the tornado, and you can blow water out due to the streamline flow, due to the entrained air. Once again, I would like to hear anybody and their comments, and you can reach me at rsdatainc